This video is going to focus on arithmetic sequences. Here's an example of an arithmetic sequence: -5, -1, 3, 7, 11. If you take a look at the graph, let's see if we can notice anything in particular about the graph. The first thing that I want you to notice is that your graph is increasing at a constant rate. If you think about how this sequence increases, this sequence goes up by 4 every time. So you keep adding 4 over and over and over again. That's going to be the same as how much you're increasing by to get from one point to the next on the graph. Each of these is going to increase by 4. The next thing that I want you to notice is that since those graphs increase at a constant rate, the points do line up. They are linear. And then finally, the last thing I want you to notice is that the points on this graph are discrete. That means they are not connected together. They are separate points. Now let's look at the table and see if we notice anything about the table. So again, the table grows by a constant rate. It grows by 4 every time. And the other thing that you should notice is that this starts at 1. If you look at the first point in the table, we've got the point 1, -5. That's because -5 was the first term in the sequence. Then if you look, 2, -1 is the next point. That's because -1 was the second term in the sequence. And then we've got the point 3, 3, because 3 was the third term in the sequence. So again, just a quick review. The graph for an arithmetic sequence is linear and discrete. The table grows by a constant rate. And then the sequence is going to start with n equals 1. That means that this first term here would be at n equals 1 in your table. So now let's see if we can figure out how to write the equation. There's a couple things that we need to figure out. We need to figure out what the growth is and then also what term 0 is. So we already talked about how this particular pattern grows by 4. We saw that on both the table and the graph. But now what we need to do is to try to figure out what term 0 would be. Remember that this was the first term of the sequence. This was the second term of the sequence. So we need to figure out what term 0 is. We're going to need to work backwards. So here again, you can see that we've got terms 1, 2, 3, 4, and 5. Now we're going to try to work backwards to figure out what term 0 would be. So remember, we were growing by 4 every time we were adding 4 to create our pattern. So if we were going to work backwards, what we would need to do is go backwards by 4. So if you do -5 and you go backwards, or you subtract 4, you get -9. So term 0 is -9. Now let's see if we can write the equation. So the equation for an arithmetic sequence is T of n equals dn plus a. N is going to stand for your term number. So those are these numbers that you see here in green. These are your n values. T of n is the nth term. So for example, T of 5 would be 11 because the fifth term in the sequence was 11. T of 2 would be -1 because the second term in the sequence was -1. These two terms are super important for the equation. D stands for the common difference. That's the same thing as the growth here. So the growth and the common difference are connected together. And then A represents term 0. And we call it A just because it's the starting term. So for this particular problem, since we know that our growth is 4, that's our D, and since we know that term 0 is -9, that's our A, our equation would be T of n equals 4n minus 9. Let's look at another example. So we've got 18, 16, 14, 12, and 10. This time our sequence is getting lower. So we're going down by 2 here. We're still going to try to use that same equation. T of n is equal to dn plus a. Since our sequence is getting lower, or since it's going down by 2, all that means is that our d value is going to be negative. So in this case, it's -2. So now we need to try to figure out what our a value is, and keep in mind that 18 is the first term of our sequence, 16 is the second term, 14 is the third term, and 12 is the fourth term, etc. So we've got our first, second, third, fourth, and fifth term. We're going to try to work backwards to figure out what would go in this blank for term 0. So if we work backwards, we know we were going down by 2. To work backwards, we're going to have to go up by 2, which would give us 20. So A equals 20. So now let's see if we can write the equation. We're just using the equation that we have over here. T of n is equal to our d value. Well, our d value is -2, and then n plus our a value, and our a value is 20. So our equation is T of n equals -2n plus 20. It's possible that you're also going to see a slightly different notation where sometimes you might see this a sub n notation. This is essentially the same thing as T of n. It's just a little bit different way to write it. If I was going to ask you for something like T of 1, you would know that that's 18 because that was the first term in our sequence. If I asked you for a sub 1, that would also be 18. If I asked you for T of 2, that would be 16 because that's the second term in our sequence. So if I asked you for a sub 2, that would also be 16. So let's see if we can fill in these blanks. So for T of n, we've got -2n plus 20. If we wanted to try to figure out our T of 0, we would get 20, our T of 1 would be 18, our T of 2 would be 16 because we've got our 0 term, our first term, and our second term. You can see that our a sub 0 is 20, our a sub 1 is 18, and our a sub 2 is 16. So again, for arithmetic sequences, you're going to use this formula right here to write the equation. T of n is equal to dn plus a. D is your generator or your common difference. It's what your sequence is either going up or down by. And then a is your initial value or your 0 term.